If I were to ask you to identify what was in this image, you would probably think of it as a trivial task. What is it? A cat? Well, it's obviously a bowl of guacamole. Well, at least according to Google's open source image recognition model, Inception. This image is clearly a cat. But why did the image recognition model fail to identify this image? Hello, my name is Ryan, and by the end of this presentation, you will understand why this image was misclassified. To understand this problem, we have to go back and look at what causes misclassification. Let's say we had a simple dataset made up of 3 distinct classes, red, green, and blue. We have trained a neural network using this dataset. The neural network has generated the following decision boundary based on its training results. If we pass any new samples into the network, it will be classified based on its location within a decision boundary. Let's say we passed in a new sample. We know it's type blue, but as you can see, it's located within the red decision boundary. This will cause it to be classified as a red despite us knowing it's a blue. This is because the neural network did not account for a potential blue sample being in this area. This is a rather extreme example, but it demonstrates how misclassification occurs. The next most obvious question to ask is, why is this a problem? Well, misclassification by the classifier poses a serious security threat to our networks. It can be used by bad actors with malicious intent to fool our neural network for their own gain. An individual with carefully modified input values can cause misclassification. This misclassification is obvious to a human, but not to a neural network. This type of attack on our neural network is called an evasion attack, and we should be concerned about it. To help us further understand evasion attacks, let's look at an example. Here on the screen, we can see we have an image of a panda bear. This untampered image was passed into an image classification network where it was labeled as a panda with 57.7% confidence. This is clearly the correct answer, and the network did well. But if we tamper the image by slightly changing the value of each pixel with noise, the image will be classified as a given with 99.3% confidence. This is more confidence than when it tried to classify the panda initially. This is a major issue, as the tampered image is clearly a panda to a human, but not necessarily to a network. Now that we understand how these attacks can occur, why should we be concerned about them? Yes, it may not matter that a panda was identified as a given, but neural networks are becoming used more and more in industry. Many of the tasks they are being used for are critical. Examples include detecting fraud in bank transactions, filtering out spam emails, medical diagnosis, and theft prevention. One of the scariest examples I can think of relates to self-driving cars. Simple strips of tape can be placed on a stop sign to cause misclassification in an image recognition model. In this case, a stop sign was misclassified as a 45 mph speed limit sign when it's clearly a stop sign. This misclassification could cause a self-driving vehicle to drive through an intersection and cause a collision. By neglecting evasion attacks on our network, we could be putting society at serious risk. Due to this risk, we should try and protect against evasion attacks. But how can we do this? One way to do this is to conduct penetration tests on our neural network. This means that we're going to evaluate the network as a whole. By understanding the limitations of our machine learning model, adversarial examples can be identified and mitigated. In addition, using information from these tests, adversarial training can be conducted. By generating examples of potential adversaries and weak points, the ability for bad actors to exploit our neural network is minimized. And another method is model bagging. Different neural networks have different decision boundaries. By bagging the results of multiple neural networks, we can get a combined model which performs better overall. This lowers the ability of an evasion attack to fool our model, as it is more difficult to fool many neural networks instead of just one. The final way to protect against evasion attacks doesn't even involve our network directly. By implementing simple algorithms to detect adversarial data, many evasion attacks can be avoided completely before reaching the neural network. This thus protects the integrity of our neural network. This finally brings me back to the original cat image we saw at the start of this presentation. We now understand how this misclassification occurred and how we can prevent it in the future. It was classified as guacamole as the values of the pixels in this image caused it to lie within the guacamole decision boundary of the neural network. The misclassification of this image was primarily caused by a bad actor. They modified the pixels within the image in a strategic manner which caused it to be identified as guacamole instead of a cat. Though it may not matter in the simple cat image, the evasion attacks like this can cause societal harm as a whole. Despite this, these types of attacks can be protected with proper measures and techniques in place. That concludes this simple presentation. Thank you for listening and have a great day.